I'm Richard Novak. I'm the Entity Product Manager for Olympus Australia, based in Melbourne. It's my pleasure to show you how to set up corrosion on the OmniScan X3. Let's begin with Plan and Calibrate. I have a plexiglass plate, this one here with some simulated corrosion in it. There is a procedure here. You can use the calibration to determine the velocity. If you know the velocity, you can just punch it in here. Thickness 12.5. I've got a RollerFORM probe, so we're going to select that, which is an IWP1. Select the RollerFORM wedge. So this is a standard way of just selecting all the probes and wedges. The important step here is to select the right process, not linear but 0 degree with overlap. And then we select the aperture size for each of our beams. So this is a quantity of 8 elements. I'm going to select 4. It shows some things better this way for me. The larger the quantity, the smaller the coverage of the probe as well. You should remember that. Okay, done. Okay, so here you see there's an interface echo and a back wall echo, and then a very small second back wall echo. At the interface echo, that could be the echo from a hydroform or a flexiform where it's material, the same with the RollerFORM, or it could be the edge of at the end of the wedge. So this can work for hard wedges as well. And what we do is we press and hold, enable the A-scan synchro. So what we're doing here is we're synchronizing everything to the interface echo. Just going to move that gate out of the way so that where the interface gate meets the interface echo will be the 0 point. So that's our 0 point, as we would find if we did a wedge delay. In this case, it replaces the wedge delay, and it does this for every single beam, every VPA that we have across our part. And then because it's a 0 there and the scale is actually exactly the correct scale, assuming your velocity is correct, so where you see the signal, you can actually immediately read off if you need to the measurement. It certainly helps with troubleshooting. Okay, the next thing we do is we set our gates. Oops. So the A gate, I normally would select first peak. That enables us to pick out smaller pits and so on, which even though the back wall may still be there and still may be larger, we want to see the pit, the top of the pit, rather than the back wall in that situation. And I usually use edge. It's a little bit safer sometimes with peak. Sometimes you have to worry about saturation of the signal and you can't measure the peak. So I use the edge in that case. If I press the little button and go down one to the next menu, we then select the A-I as the thickness measurement. And now you'll see up on the right hand side where the thickness is, it says T A-I 12.57. Okay, so we've got the right answer. Next thing is to look at sensitivity. So if we notice that the back wall echo is much smaller than the interface echo. That's because of material attenuation. So we'll do a TCG, a manual TCG, to compensate for that. So obviously the first point, there's no gain, we just add that. And then the second position, I'll make that the back wall echo, 12.5. And now we'll increase the gain slowly until it's the same as the interface echo. So that means that if there's any echo, if that's any back wall, if you like from corrosion, will show the same size. It also means that if we can pick up a pit near the top and a pit near the bottom, they should all both show the same size. Okay, so we've done that. So now we can go along here. Oh, one more thing. I'll go along. I'll put some coupling down.